Okay. All right, so we are going to solve square root and other radical equations. Now, the only difference between this and other algebraic equations you've seen, obviously, is the inclusion of the square root. The good news is the way you go about solving algebraic equations is the same as you're going to go about solving this equation. So put your Algebra 1 thinking caps on. What? When we solve an algebraic equation, what's our goal? To solve for x, correct. And how do we solve for x? What are we trying to do to that variable? Isolate it. Good. So that's what we're going to do here. We're going to isolate. This time, where's my variable? My variable is underneath the radical sign. So in order to isolate x, we have to isolate the radical sign. So here in this problem, we have a 5. So we're going to move 5 from the left side of the equation to the right side of the equation by subtracting. Okay, now, looking at this, does anybody have any thoughts? Just period, I want to know if you have any thoughts. No. Do you have any thoughts about how we're going to get that x out from underneath the radical sign? What do you think?
Oh, the same as the other one. Put it on a line.
No.
A division one
No.
over it.
No. Good answer, though. Miriam? What do you want to divide by? No. No need to divide. Matt? No. It's stuck underneath the radical sign. You can't divide. Well, it's already a square root. So what do we want to do to get rid of that square root?
The opposite of the square root.
Which is what?
I don't know.
Lucas? Hey, what did you say? You were talking over Alex.
Square root of 3, 4, 5.
No? You guys are close. What's the opposite of finding the square root of something? What? Square each side. Very good, Leticia. Remember, when you have something underneath the radical sign, if you square that, what do you end up with? If I take the square root of 6 and I multiply it by the square root of 6, what do I get? 6. You get the thing that was under the radical sign. So that's what we do. We're going to square both sides. What happens on the left side is simply my radical disappears. On the right side, 5 squared is 25. Now I have a two-step algebraic equation. I subtract 4 from both sides. I get 3x equals 21. I divide both sides by 3. Gives me my final answer of 7. I could say yes, but that would be a lie. What's the matter? problem where instead of a radical, we start with a fractional exponent. Now, basically the steps are going to be the same. Basically. It is a little bit more complicated. I don't think it's more difficult, but it is more complicated. But if you understand the process of what we just did, you will hopefully understand the process of this. So again, our goal, instead of isolating the radical, is to isolate the exponent. So what do you think is the first thing that I'm going to do here? If I want to get this by itself, what do I have to do?
Subtract.
That's not subtraction.
Or multiply.
That's not multiplication. That's division. It's 3 times that stuff. 3 times x plus 1 to the 2/3 power. If it just said 3x equals 12, what would you do? You would divide. So just because it says 3 times something else doesn't change the way you do the problem. So we're going to isolate the fractional exponent by dividing each side by 3. So I divide this by 3 and 12 by 3. It gives me the same thing on the left without the 3. 12 divided by 3 is 4. Okay, let's see who's really on the ball today.
Which one?
The beach ball. How can I get rid of this fraction? What can I do to it that will make it disappear?
Oh, radical.
Jillian?
You can multiply it by
By?
the reciprocal.
Excellent. That's exactly what I'm going to do. I'm going to multiply this by its reciprocal. But remember, if I do something to one side of an equation, I have to do it to the... It looks much more complicated than it actually is. Don't get thrown off by the parentheses. That's just saying that x plus 1, here's x plus 1 is in parentheses, and then the whole thing with the 2/3 is in parentheses, and we're multiplying both sides by 3 over 2. Multiplying.
Oh, step 1 is multiplying?
No, step 1 was, because this is 3 times this, we divide by 3. If the
Divide
problem,
what by 3?
this and 12.
Okay.
Laura, if the problem was just this,
No, I get it. Yeah.
right? And I asked you to solve for x, what would you do? You divide by 3, right? Same thing here. There's just a lot more than just x. But we're still going to divide by 3 to get rid of the 3 on the left side.
Right.
Okay, so now here, right, let's focus on this for a second. What's going to happen when I multiply 2/3 by its reciprocal? What am I going to get? What's 2/3 times 3/2? 6 over 6, which is 1. So the left side is going to be 1, x plus 1 to the first power, which is x plus 1. And then here I'm going to get 4. I don't do anything here. I get 4 to the 3/2 power. It says 6 over 6 because 2/3 times 3/2 is 6 over 6. But 6 over 6, as we all know, is just 1. So you can actually just cross it out. You can leave it off. You can put 6 over 6 and cross it out like I did. Whatever you want that makes you understand that the exponent disappears. 250. Okay, now the next step is to get rid of this exponent. So we've already learned how to do that. We're going to turn it into a radical. The index goes with step number 4. So we're going to simplify 4 to the 3/2 power. It's the square root of 4 raised to the 3rd power, which is 2 raised to the 3rd power, which is 8. So that's how we get x plus 1 equals 8. Yes, sir?
I know you said this, and I'm sorry, but is that 6 you crossed out?
6 over 6.
Yeah.
Okay, again, I just didn't have room to do it over there, so I'm doing it over here. And turning this is what we did in the Bell problem. This is what we've done yesterday. We take this fractional exponent, we turn it into an actual value.
Wait, so step 3. What do? I'm just confused because you have 4 and
You
then 3
just
over
changed
2.
the 4.
What am I writing down first? The x plus 1?
Right, x plus 1 equals 4 to the 3/2 power.
Okay.
Then, x plus 1 equals 8. And this over here is how we went from 4 to the 3/2 power to 8. 4 to the 3/2 power becomes the square root of 4 raised to the 3rd power. Square root of 4 is 2. 2 to the 3rd power is 8. Okay, now, remember we talked about absolute value and how I told you to ignore it? Well, we have to bring it back. So now, because the index is 2, we have to use absolute value. So we're going to just make this absolute value of x plus 1 equals 8. And again, that's only going to be when your index is an even number, like it is here. Now the reason that this is important is it means we're going to have 2 answers. Remember, when you take the square root, when you just take the square root of a number, you actually get 2 values. So the square root of 25 is 5 and negative 5. So here we have not that x plus 1 equals 8, but the absolute value of x plus 1 equals 8. So what you're going to end up with is 2 equations. Let me finish. The first equation, which is just x plus 1 equals 8, you rewrite it. The second one is x plus 1 equals the opposite of whatever your first equation is. So the first one was 8, the opposite is negative 8. Then you solve both equations, you get 7, and then you get negative 9.